Hello everyone and welcome to Gumno YouTube channel. Today topic I would like to show you all about the configuring RIP. Well, before we start to configure RIP on the router TK, router BB and router PP, the first thing you need to know what is RIP and why we need RIP. Okay, so now let's go to see the introduction all together. RIP stands for Routing Information Protocol. It's a dynamic routing protocol which use hop count as a routing metric to find the best path between the source and the destination network. Base route with lower hop count. It is a distance vector routing protocol which has AD value 120. Defines a hop count greater than 15 as unreachable route. Cannot see the visibility of entire network. Send broadcast update routing content every 30 seconds. Classful routing protocol, RIP version 1. RIP have two versions, RIP version 1 and RIP version 2. For the RIP version 1 is classful routing protocol. Do not send subnet mask information with their routing update. So it don't support RIP version 1 don't support VLSM. Okay. For the RIP version 2 is a classless routing protocol. It supports VLSM. Okay. Okay, so as you can see in my network diagram, we have five network, network 1, network 2, network 3, network 4, and network 5. The five network connect together through three router TK, router BB, and router PPs. Okay, so to allow computer W7 to communicate with the computer I2012, we need to configure routing protocol on these three routers. Okay, in my case, I choose RIP to configure on the router TK, router BB, and router PP to allow this router to know the remote network of each other. Okay, so what is the base route that calculate by routing information protocol to each remote network? Okay, as you can see in the picture, from the router TK to the network 192.168.5.0 of the router PP, we go to the network from the router TK. We can go to this network by two different interface. Interface fast Ethernet 2/0 and interface serial 5/0. Okay, so which interface is the base route from the router TK to network 192.168.5.0 of the router PP. Okay, RIP choose serial 5/0 is the base route to the network 192.168.5.0 of router PP from the router TK because the interface have lower hop count, only one router. Okay, so from the router TK to the network 192.168.5.0, RIP choose the serial 5/0 is the base route because have lower hop count, only one router. Okay, even though bandwidth of the serial is lower than bandwidth of fast Ethernet, RIP don't care about the bandwidth. RIP care only hop count. Base route to remote network base route to destination network with lower hop count. Okay, so now we will move to the step to configure. Okay, step 1, configure routers. From global configuration mode, configure the host name of each router as in diagram. Okay, router TK, router BB, and router PPs. Okay. Then configure console, virtual terminal, and enable secret password. And next configure interfaces as according to the network diagram. Okay, so let's start the step 1 all together. Okay, so I go to the IIS of the router TK. Okay, I already connect to the IIS of the router TK, as you can see, and I already config the host name. Okay, so we move to the global configuration mode to configure console virtual terminal and enable secret password. Okay, so now we are on global configuration mode of the router TK. So we start to configure console password with the command line console 0. Okay, password Cisco. I put password console Cisco and then log in. Okay. Okay, and then we move to configure virtual terminal password. So we type command exit to exit from specific mode. To configure virtual terminal password, we enter the command line vty 0 space 4. I select file line to allow remote access from the client, to allow file user remote access to the router TK at the same time. Okay, and then command password, I put password 123 and then log in. Okay, and then we type command exit to exit from the specific mode and then start config enable secret password with the command enable secret class. Okay, I input the password class. Okay, now we finish config the password on the router TK, so we will move to config password on the router BB. Okay, as you can see now, I already connect to the IIS of BB, and now we are on privilege execute mode. I already config the host name, so we move to the global mode to config the password. Okay, line console 0 password Cisco log in and then exit from specific mode to global mode and then configure virtual terminal password with command line vty 04. It means we select file line, allow file user can remote access from client machine to router BB at the same time. Okay, and then with the command password 123 log in. Okay, and then exit. Okay, and then we will configure the enable secret password with the command enable secret class. Okay, so now we already config password on the router BB, and then we will move to config password on the router PP. As you can see, I already connect to the IIS of the router PP. Okay, so move to global configuration mode to config password. Okay, first we config console password with the command line console 0 password Cisco log in. Okay, and then exit from specific mode to start configure virtual terminal password with the command line VTY04 password 123 login. Okay, exit. Okay, now we have already configured password of the 3 router, so we will move to the next. Okay, configure interface as according to the network diagram. Okay, so configure interface of each router. Router TK have 3 interface, fast Ethernet 0/0, IP 192.168.1.1 with the subnet mask /24, fast Ethernet 2/0, IP 192.168.3.1 with the subnet mask /24, and serial 5/0 IP address 192.168.2.1 with the subnet mask /24. Okay, and serial 5/0 is DCA, so need clock rate. Okay, so let's start to configure interface of the router TK altogether. Okay, interface 5 0/0, IP address 192.168.1.1, subnet mask 255.255.255.0, and then open the interface with the command no shutdown. Okay, and then we move to configure another interface 5/2/0, IP address, as you can see in the diagram, 192.168.3.1 with the subnet mask /24. 192.168.3.1 subnet mask 255.255.255.0, and then open the interface with the command no shutdown. Okay, and then move to configure another interface, serial 5/0, IP address 192.168.2.1, as you can see in the diagram, .2.1 with the subnet mask /24. Okay, subnet mask 255.255.255.0. Clock rate, I select 44, I select 64,000. Okay, clock rate 64,000. Okay, and then open the interface with the command no shutdown. Okay, now I already configured the interface of the router TK. So now move to configure interface of the router BB. As you can see in the picture, router BB have 2 interface. Fast Ethernet 2/0 with IP 192.168.3.2 with the subnet mask /24, and interface Fast Ethernet 3/0 with IP 192.168.4.1 with the subnet mask /24. Okay, so let's go to configure the interface of the router BB together. Okay, let's start now. Interface Fast Ethernet 2/0, IP address 192.168.3.2, subnet mask 255.255.255.0, and then open interface with the command no shutdown. Okay, another interface 5/0 3/0, IP address 192.168.4.1, subnet mask 255.255.255.0, and then open interface no shutdown. Okay, now I already configured the interface of the router BB, so next we we will move to config interface of the router PPs. Okay, as you can see in the diagram, router PP have three interface. Interface fast Ethernet 0/0, IP address 192.168.5.1. Interface fast Ethernet 3/0 with the IP 192.168.4.2 with the subnet mask /24 and interface serial 5/0 with IP 192.168.2.2 with subnet mask /24. This interface is DTE, no need clock rate. Okay, so let's start to configure interface of the router PP together. Okay, so let's start now. Interface 5/0/0 IP address 192.168.5.1 subnet mask 255.255.255.0 interface 5/3/0 IP address 192.168.4.2 with the subnet mask 255.255.255.0 and then open that interface with the command no shutdown. Sorry, no shutdown. Okay, and interface fast Ethernet 0/0. I not yet open the interface, so I go to that interface again and then open the interface. Okay, interface fastnet 0/0, no shutdown. Okay, and we have another interface of the router PP interface serial 5/0 with the IP 192.168.2.2 subnet mask /24. Okay, interface serial 5/0 IP address 192.168.2.2 subnet mask 255.255.255.0 and then open interface with the command no shutdown. Okay, now we already configured the interface of the three routers. So we move to the next step. Okay, we move to the next step. Step 2, configure the computer. Configure the computer with the proper IP address, subnet mask, and default gateway as shown in the diagram. Okay, and then check connectivity between the computer by using ping command from the W7 computer attached to the router PPs. Okay, ping the I2012 server attached to the TK router. Okay, and then check the result. As you can see, reply from the default gateway with the destination unreachable. Okay, and why did the ping fail? Okay, because PP router does not know the path to remote network. Okay, so why does PP router don't know the path to remote network? Because no routing information, because no routing protocol is configured on the PP router. Okay, so now let's start the step 2 altogether. As you can see in the diagram, okay, step 2, we need to assign IP address to the W7 computer and to the I2012 computer. Okay, I already assigned the IP address, subnet mask, and default gateway address properly. Okay, I just check for you. This is the computer I2012. Okay, so I check the IP configuration. Okay, for you. Okay, I already assigned IP address. Okay, properly. IP 192.168.1.1, subnet mask 255.255.255.0, default gateway 192.168.1.1, and DNS server address 192.168.1.2. Okay, so I already assign IP address to this machine already. Okay, and then I check another machine. Okay, this is the machine name W7. Okay, so I just check for you. I already assign IP address to it. Okay, as you can see, I already assigned the IP address 192.168.5.2, subnet mask 255.255.255.0, default gateway 192.168.5.0. Okay, and DNS server, I change the DNS server address. DNS server address is 1 2. Okay. Okay, I check again to confirm. Okay, and then we try to ping from the PC W7 to the PC I2012. Okay, so let's start to ping all together. So we go to the command prompt CMD. Okay, and then using the command ping 192.168.1.2. This is the address of the I2012 computer. Okay, and then press enter. Okay, as you can see, the message reply from the router. Okay, from the router. Okay, destination host unreachable. Okay, it means that computer W7 and computer I2012 cannot communicate with each other. Okay, the reason that this computer cannot communicate with each other because on this router we not yet configure routing protocol, so all the router don't know the remote network of another router yet. So computer W7 attached to the router PP and computer I2012 that are attached to the router TK cannot communicate with each other because we not yet configure routing protocol on these three routers. So these three router don't know path to remote network of another router. It just know path to the directly connected networks. Okay, so we will move to the next. Okay, step 3, check the routing table in tree of all routers to verify. Okay, so using the command show IP route. Okay, view the IP routing table of each router. Okay, so let's start now. Okay, so I exit from the specific mode to privilege execute mode. Okay, to view the routing table of the router TK, you use the command show IP routes. Okay, as you can see now on the router TK, just only know the network that are directly connected. Okay, as you can see, know this network because this network is directly connected to the fast Ethernet 0/0. Okay, this network also connect to the serial 5/0 directly connected network, and this network is directly connected. So router TK don't know remote network yet. Okay. Okay, and then move to check the routing table of the router BB, show IP route. Okay, as you can see, router BB also no directly connected. This is the directly connected, and this is the directly connected network. So router BB don't know remote network yet, okay, because we not yet configure routing protocol on it. Okay, and then move to check the routing table of the router PP to verify show IP route. Okay, as you can see, the router PP just know the network that directly connected. Okay, directly connected. This network is also directly connected, and this network is also directly connected. So the router PP not yet know remote network of another router. Okay, because we not yet configure routing protocol on it. Okay, so now we will move to the next step. Okay, but before we will move to the next step, okay, I would like to talk some things. Okay, if router don't have remote network information in the routing table, so it cannot forward package from any sources to any destination host which are located in those remote network. The solution, we need to use routing protocol. Okay, okay, so to allow the router to know the remote network of another router, the solution, we need to use routing protocol. In my case, I will use RIP, routing information protocol, to allow the router TK, router BB, and router PP to know remote network of each other. So computer that are connected to this computer can communicate with each other, because the router know remote network of each other through routing protocol. Okay, okay, before configure RIP on the router from the privilege execute mode of each router, you can enter debug IP RIP command to see RIP process. After you have completed monitoring the process, you should turn off debug IP RIP with the no debug IP RIP command. Okay, so now let's move to the step 4, configure RIP on all router to allow each router to know remote network of each other. Okay, of another router. Okay, so let's start now. I start from the router TK. So to see the RIP process, you can type the command debugs IP RIP. Okay, and then as you can see, RIP protocol debugs is on, and then move to global mode to configure RIP. Okay, so to configure RIP, you can follow this step. From the global configuration mode and enter the command router RIP, enable RIP, and then command network with the network address. Okay, so router will use routing information protocol to update the network to another routers. Okay, that already enable RIP. Okay, so the router will exchange network with each other by using RIP protocol. Okay, okay, so let's start now. Okay, router, we type the command router RIP and then network. Okay, as you can see, router TK have 3 network: 192.168.1.0, .2.0, and .3.0. Okay, so network address 192.168.1.0, 192.168.2.0, and 192.168.3.0. Okay. Okay, so now we finish config the RIP on the router TK, and we will move to configure RIP on the router BK. Okay, as you can see the RIP process. Okay, as you can see the RIP process, it will send the update routing table. Okay, send the update routing table. Okay, to all router. Okay. Okay, to destination IP address 255.255.255. Okay, so after you already see the process of RIP, you can turn off. Okay, turn off debug IP RIP with the command no debugs IP RIPs. Okay. Okay, and now we will move to configure RIP on the router BBs. Okay, so you can go to the global mode, router RIP. Okay, and then network. Okay, as you can see in the diagram, we have two networks of the router BB, network 192.168.3.0 and network 192.168.4.0. Okay, 192.168.3.0 and another network .4.0. Okay, so now we already finished config RIP of router BB. So move to config RIP on the router PPs. Okay, so move to global configuration mode and then command router RIP to enable RIP. Okay, and then command network to broadcast network to neighbor router. Okay, we have three network of router PP, network 192.168.2.0, network 192.168.2 sorry .4.0 and network 192.168.5.0. Okay, so 192.168.2.0, another network .4.0, and the last network of the router PP is .5.0. Okay, so now we already finished config RIP on these three routers. Okay, so we will move to the next. Okay, verify the new root of all router. Okay, why do you see? Okay, so let's start to verify the new root of all router with the command show IP root. Okay, so let's start from the router TK. Okay, you can show IP root to verify the routing table again. Okay, as you can see now, router TK no path to remote network. Okay, this is the remote network. Okay, network 192.168.4.0. Go to this network through the interface Far Ethernet 2/0. Okay, pass only one router. Okay, and another remote network 192.168.5.0. Go to this network through interface serial 5/0. Okay, hope count 1. Okay, hope count 1. This remote network router learn from RIP. As you can see, code or stand for RIP. Okay, so from the router TK to the network 192.168.5.0, go to through interface serial 5/0. Okay, go to through the interface because have lower hop count. Okay, so now we will move to the router BB to check the routing table again. So IP root, okay, as you can see now, router BB no path to remote network. This is remote network case. Okay, no path to remote network through routing information protocol. Okay, through RIP. And we can move to the router PP to check the routing tables again with the command show IP root. Okay, as you can see now, router router PP also no path to remote network. The remote network remote network. Okay, so now all router no remote network of each other. So computer that are connected to these three router can communicate with each other. Okay. Now we will move to the next. Save the router configuration. Okay, by type command copy run start. Okay, so I start from the router TK. From the privilege execute mode, you can type command copy run start to save router configuration. Okay, enter confirm. Okay, and then move to the router BB to save router configuration with the command copy run start. Okay, enter confirm. Okay, and then move to the router PP to save router configuration with the command copy run start. It means we save running configuration file from RAM to store in startup configuration file in NVRAM. Okay, so we will move to the next step. Okay, the last step, ping host to host again. It means ping from the computer, okay, W7 to the computer at 2012. Okay, and then you can monitor the result. Okay, the ping is successful. Why? Okay, in now the ping will successful because all router no remote network of each other. Okay, so let's start to test now. Okay, so from the computer W7, I will ping to the computer at 2012 again. Okay, as you can see now, have reply from the computer with the IP address 192.168.1.2. Okay, as you can see, send 4, receive 4. Okay, loss 0% loss. It means computer W7 and computer I 2012 can communicate with each other because our three router now no remote network of each other through routing information protocol. Okay, as you can see in the picture on the I 2012, we have a website with the domain name www.labkhmer.com, so I can access this website from the computer W7. Okay, so let's start to test. Okay, so I open browser. Okay, and then type domain name www.lovekhmer.com. Okay, wait a moment. Not found, error. Okay, I check the configuration of the website. Okay, I go to this server. I check the DNS. Okay, I check the DNS configuration. www.lovekhmer.com with this IP. Okay, I try to test again from the computer. Okay, I test connect through the IP address 192.168.1.2. Okay, not found, still not found. Okay, maybe problem with the website. Check. Okay, I try to add the website again. I try to add website again. Wait a moment, okay. Okay, so now let's test again from the client machine. Okay, as you can see now we can access to the website. Okay, this is my website. Okay, so I can access from the domain name www.khmer.com. Okay, so we can access to the website now. Okay, so it means that our machine W7 and our machine at 2012 can communicate with each other through these three router, because all these three router we already have config routing information protocol on it. So through this protocol, this router can know the remote network of each other. Okay, so my video today is now finished. Finally, I would like to say don't forget to subscribe and share my video. Thank you so much for watching. Bye. See you next time.